Okay, in this one we've got information on X, number of customers, and Y, pounds in takings, at a butcher's shop, and we've got a scatter graph of it, and we have got to talk about, okay, which is the independent variable. Okay, so terminology. Independent is the one that you think is fixed at some level, and then the dependent one is the one you think might vary according to that. So do we think that if we had more customers, fixing that would cause the takings to be bigger or smaller, or do we think that the takings comes first and that determines the number of customers? Okay, well, clearly we think that if there's different amount of takings, that's caused by different numbers of customers. So it's the number of customers that's the independent variable, because we think that the number of takings depends on the number of customers, not the other way round. Okay. Then we are suggesting that maybe we should use a regression line. So does that seem to make sense? Well, we look at the scatter graph and we see that, okay, it does seem to be fairly close. A linear model does seem to make sense. Okay, there aren't any massive outliers. There's no non-linear relationship. So yes, it seems sensible to draw a line through those points. So it seems a reasonable suggestion. Then we need to calculate the equation of the least squares regression line. So we need a value of A, we need a value of B, and your calculator will tell you those if you enter that data into your calculator. So some easy marks for putting the data in your calculator, getting an A and a B, and then it is good. You should write out the equation in that form, and then we've got to interpret the value for B. Now graphically, okay, B is the gradient of this line, but you'll get no marks for just saying B is the gradient. You've got to do it in context, okay, and you've got to know what gradient means. So the gradient is how much you go up every time you go across by one. So every time we have one more customer, it's how much the takings goes up by. So it's the increasing of takings for each extra customer, or it could even be what you think each extra customer is likely to pay. Why has my value for A got no practical interpretation? Well, that will depend on what the value of A is, okay? But just from the line I've drawn here, I wouldn't be at all surprised if A was a negative value, which suggests that when there are no customers, the takings would be negative. Well, that can't possibly mean anything in reality. So maybe the relationship isn't linear down here, or maybe it's just, you know, a small error in the measurements. So either way, we can't actually attach a significance to if no one comes into the shop, you lose money. It's not going to happen. So you have to say that's not realistic. Okay, so you have to state what the value of A is, and then if it's negative, you have to explain why that would not make sense in the context of the problem. And then we've got to estimate to the nearest £10 the takings when the number of customers is 50. So we've got an X value. So you sub your X value into your regression equation, and out comes the Y value. And then we've got to explain why the manager of the butcher shop may be interested in using the regression line. Okay, so they may have different numbers of customers on different days. If they can predict their number of customers, okay, then they can get an idea of how much each customer is worth, and being able to predict their takings might be useful. So on the marks team, you can see they want the word predict or the word forecast in order to decide what's going on. This is a bit vague, in order to improve their business model. But you've got to make it kind of seem like you have thought really about what the butcher might want to do with it. Okay, and then the rest of the question, you can see the other comments as we have discussed. Okay, I don't like this one here. I would expect to be okay, so in fact it wasn't negative, it was a positive value which was here. So I would like you to see for this one, okay, that getting £67.5 of takings when there are no customers is not sensible. Okay, it doesn't have to be a negative answer just to be not sensible. You wouldn't expect any takings at all when the number of customers is 0. Okay. All right. Each extra customer increases takings by £10 would be absolutely fine for that one. This is just another way of saying it. Okay, hope that helps.